Hello and welcome to this video from Heybridge High School Maths Department. Today we're going to look at Unit GM10 Objective 6, solving geometric problems involving algebra and equations. So here we have a diagram of a garden with 4 flower beds, and the garden is a rectangle 23 metres by 17 metres, and each flower bed is a rectangle with the same length and the same width. Work out the length and the width of the flower bed. So let's let W be the width of one of the flower beds. So that will be W, and I've got 4 of those. So altogether I've got 4 widths. So I'm going to have 4W. And then in between each of the flower beds, and in between the flower bed and the edge of the garden, I've got 1 metre. So I've got 1, 2, 3, 4, 5 metres there. So the entire width of the garden would be 4W plus 5. And then if I have a look across the top, my total width is 23. So those 4 flower beds plus the 5 metres in between them must be equal to 23 metres. So I'm going to take away 5 from each side, because now that I've written that down, I've just got a nice simple linear equation to solve. And that's going to give me 4W is equal to 18. Then I'm going to divide both sides by 4. And that's going to give me W is equal to 4.5. And it's important to remember the units. W is 4.5 metres. So now let's have a look at the length. So this is the length of the flower bed. I'm going to call that L. So let's let L equal the length of a flower bed. I'm going to do exactly the same thing. So the complete length, I'm just going to have L. I know I've got 4 flower beds, but down that 17 metre width, I've only actually got 1 length. Sorry, 17 metre length, I've only actually got 1 length. And then I've got 1 metre either side between the flower bed and the edge of the garden. So I'm going to have L plus 2 equals 17. Subtract 2 from both sides. L is equal to 15 metres. So the width of my garden, the width of one flower bed is 4.5 metres. And the length of one flower bed is 15 metres. So our next question, shown below is an isosceles triangle. Each side is measured in centimetres. Calculate the perimeter of the triangle. Now for the perimeter of the triangle, we would add together the lengths of all the sides. But we need to find the value of x first. Because we know that the side labelled 3x minus 1 and the side with length x plus 9 are the same length, we can put those two sides as equal to each other in order to find the value of x. So I've got an x here, I've got 3x here, so I'm going to move the smallest x. So I'm going to subtract x from both sides to begin with, and that's going to give me 2x minus 1 is equal to 9. Then I'm going to add 1 to each side, and that will give me 2x is equal to 10. Then I'm going to divide both sides by 2, and that's going to give me x is equal to 5. Now I can substitute that value of x into each of these side lengths to find out how long they are. So I know that these two are the same length. So 3x minus 1 and x plus 9 have got to be the same length. So I'm just going to work out x plus 9 because it's the easiest one. So 5 plus 9 is equal to 14. So this side will be 14 centimetres and this side will also be 14 centimetres. And then I can work out this side here at the bottom. So x is 5, 5 plus 1 is equal to 6. So this side is 6 centimetres. And then to find the perimeter of the triangle, I'm just going to add those up. So I'm just going to do 14 plus 14 plus 6, and that will give me 34 centimetres. So the perimeter of my triangle will be 34 centimetres. So here we have a cuboid and a cylinder, and we're told that their volumes are equal. And they would like us to find h in terms of x and give our answer in its simplest form. So let's begin by working out the volume of the cuboid in terms of x and h. So to find the volume of a cuboid, I multiply the length by the width by the height. So I'm going to multiply x by h, and that will give me h x squared. Volume of a cylinder, that's pi r squared, so the area of the circular face at the top, multiplied by the height. So the volume of a cylinder is pi times r squared times height. So that's going to be pi times x squared times 3x. So that's going to be 3x cubed pi. Now I'm told that the volume of the cuboid and the volume of the cylinder are equal. So I can put the volume of my cuboid, which is hx squared, as equal to 3x cubed pi, which is the volume of my cylinder. Now I want to get h, the height, in terms of x. So I'm going to divide both sides by x squared. And that will give me h is equal to 3x cubed divided by x squared. So remember, when we divide, we subtract the indices. So I'm going to do x to the power of 3 take away 2. And that would give me x to the power of 1, which we just write as x. So that will give me h equals 3x pi. So that's h in terms of x. So now we're going to have a look at a higher level question which involves some circle theorems. So A and B are points on the circumference of a circle with centre O. CA is a tangent to the circle. Angle CAB is 2x. Prove that angle AOB is 4x. So OA is a radius of the circle and AC is a tangent. So angle OAC here is going to be 90 degrees. Because it's the point on the circumference where a radius and a tangent meet. Remember, where a radius meets a tangent, the angle at the circumference is 90 degrees. So angle OAB will be 90 degrees minus 2x. Now, because triangle OAB is isosceles, so OA and OB are both radii, so they will both be the same length. Angle ABO, so the other angle at the circumference, will also be 90 degrees minus 2x. Now, the angles in a triangle sum to 180 degrees, so now we can work out angle AOB. So if the angles sum to 180 degrees, angle AOB is going to be 180 degrees, take away 2 lots of 90 degrees minus 2x, because we're going to have to subtract angle OAB and angle ABO, which we've already calculated. So that will give me 180 degrees minus 180 degrees, and then negative 2 multiplied by negative 2x will give me plus 4x. And if I simplify that, I will get 4x. So I've shown that angle AOB is equal to 4x as required. This time we've got a cone, and we're given that the base has got a radius of x centimetres and the slant height of the cone is 10 centimetres, and the total surface area of the cone is 39 pi centimetres. And we need to show that x squared plus 10x minus 39 is equal to 0. So the equation for the surface area of a cone is pi r squared plus pi rl, where L is this slant height here, this length. So let's substitute our values in. So we've got pi times radius squared, which will be x squared, plus pi times radius, which is x, times 10. And that's equal to 39 pi, which is the surface area that we're given here. So if we simplify that, we're going to get pi x squared plus 10 pi x is equal to 39 pi. Now we're going to divide through by pi because we've got a pi in every term on both sides of this equation. So let's get rid of pi. So we're going to divide through by pi. We're going to be left with x squared plus 10x equals 39. And then we're going to subtract 39 from both sides, and that will give us x squared plus 10x minus 39 equals 0, and that's what we were looking for. And now it says, hence find the length of the radius. So what we need to do, the radius is x, so we need to solve this quadratic equation that we've generated in order to find x. So let's have a look. So we've got x squared plus 10x minus 39 is equal to 0. So I need two numbers that will multiply together to give me negative 39, but when I add them together, they're going to give me positive 10x. So I think that I'm going to need 13 and negative 3. So 13 take away 3 will give me 10. 13 multiplied by negative 3 will give me negative 39. So I'm going to have x plus 13, x minus 3 equals 0. So the two values of x which satisfy this quadratic equation will be minus 13 and 3. Now, we're looking for a radius. A radius is a length. The radius has got to be positive. So we can exclude x equals minus 13 because we can't have a length that's minus 13 centimetres long. So the only solution that actually makes sense in this context is 3. So our radius will be 3 centimetres. Here we've got a right angle triangle and we've got sides measured in centimetres, but all of the side lengths are given in terms of x. And we need to show that x squared minus 5x minus 14 is equal to 0. So we're going to use Pythagoras' theorem. So we're going to square and add the two shorter sides. We're going to put that as equal to the square of the hypotenuse. And remember, the hypotenuse is always the side that's opposite the right angle. It's the longest side. So we're going to have x plus 5 squared plus x minus 2 squared is equal to 2x minus 1 squared. And remember that when we expand brackets, we always use boxes. Brackets means boxes. So let's expand this first bracket. So we've got x plus 5 multiplied by x plus 5. So that's going to give us x squared plus 5x plus 5x plus 25. So let's pop that down here. X squared plus 5x plus 5x will give us 10x plus 25. Now we're going to expand our second bracket. So we're going to have x minus 2 multiplied by x minus 2, and that's going to give us x squared minus 2x plus 4. So if we add that onto here, we're going to get x squared. We've got negative 2x plus negative 2x, so minus 4x plus 4. And then let's expand our final bracket. So we're going to have 2x minus 1 multiplied by 2x minus 1, and that will give us 4x squared, negative 2x, negative 2x, and a positive 1. So we're going to get 4x squared minus 4x plus 1. So I'm going to tidy this up, this left-hand side. So remember, always put a line before each sign, and then you know which term the negatives and positives go with. So I've got x squared plus x squared. That's going to give me 2x squared. I've got a positive 10x and a negative 4x, so that will be 10x take away 4x. That's going to give me plus 6x, and then I've got a positive 25 and a positive 4. 25 plus 4 is 29. That's going to be equal to 4x squared minus 4x plus 1. Now I've got 4x squared on the right hand side, I've got 2x squared on the left hand side, and I'm always going to make sure that I'm subtracting the smallest number of x squared, so the smallest coefficient of x squareds, or adding it if necessary. I'm never going to move that 4x squared on the right hand side. So I'm going to subtract 2x squared from both sides. That will give me 2x squared on this side. I'm also going to subtract my 6x because I want to end up with a 0 on the left hand side and all of my terms, everything else on the right hand side. I'm going to subtract a 6x from there. So I've got negative 4x, take away 6x, that's going to give me negative 10x. Then I'm also going to take away 29 from both sides. And that will give me 1 take away 29, which will give me 28. And over here I'm going to have 0. Now I can divide this through by 2. So I can divide both sides by 2. So 0 divided by 2 is going to give me 0. And then I just divide each term in my expression on the right hand side by 2. And then I'm just going to switch the expression and the 0 around so that my equation is equal to 0, with the 0 on the right hand side, because we've been asked to show that. So we need to write our final answer in that form. And as you can see, what's being asked for in the question matches what I have down here. So I've completed that question. I've done what they've asked. I've shown that x squared minus 5x minus 14 equals 0. Now I need to find x. So I've got this equation. I'm going to factorise that. So I'm going to have a look and I'm going to say, okay, I need two numbers that multiply together to give me negative 14, and they also add together to give me negative 5x. So I can see that this is going to be negative 7 plus 2 will equal negative 5, and negative 7 multiplied by 2 will give me negative 14. So this equation is going to factorise to x minus 7, x plus 2 is equal to 0. So either x equals 7 or x equals minus 2. Now, if I take x equals minus 2 and I substitute it into this, x minus 2, negative 2 minus 2 is going to give me minus 4, which would mean the length of that side would be minus 4, and that isn't possible because I can't have a negative length, as we spoke about in the previous slide. So x has got to be 7, and we're going to state here x is 7. Now we need to find the area of the triangle. So if we remember, the area of a triangle is half multiplied by base multiplied by height. So this is our base and this is our height. So our base, so when x equals 7, our base will be 7 take away 2, which will be 5, and our height will be 7 plus 5, which is 12. So our area is going to be half times 5 times 12, and that will give us 30, and remember your units, centimetres squared. We have here a kite ABCD, and we need to prove that cos BAD equals 1 minus x squared over 50. So what I'm going to do first of all, I'm going to draw a line across here, and I'm going to say that's 60 degrees and that's 60 degrees. Because if those two sides are both x, this isosceles triangle BCD, these two base angles have got to be equal. So this triangle is actually an equilateral triangle, which means that all of the sides will also be of equal length. So that side there has to be x. And now we're going to use the cosine rule to show what cos BAD is. So if we begin, we know the cosine rule, if you remember, is a squared equals b squared plus c squared minus 2bc cos A. Now remember, B and C are the two sides that enclose the angle. It doesn't matter which one you choose to be B and C. The important thing is that you pick A to be the side opposite the angle. So in this case, A is going to be x. So I'm going to substitute this in. So I'm going to have x squared equals, B and C are both equal anyway, so it's going to be 5 squared plus 5 squared minus 2 times 5 times 5 times cos BAD. And then let's simplify that. So we're going to get x squared equals, well, 5 squared plus 5 squared is 25 plus 25, which is 50. Take away, so negative 2 times 5 times 5, so we're going to have take away 50 cos BAD. Okay, now let's factorise the right hand side. So let's do x squared, let's take out 50 as a common factor, 1 minus cos BAD. Then let's divide both sides by 50. So we're going to get x squared over 50 is equal to 1 minus cos BAD. Then we're going to add cos BAD to both sides. So we're going to get x squared over 50 plus cos BAD is equal to 1. Then we're going to subtract x squared plus 50 from both sides. So we're going to get cos BAD is equal to 1 minus x squared over 50. And if we have a look at what we were asked to prove, we're there. So we can just write as required, and our proof is complete. Our final question, we've got a lovely circle theorems question here. So we've got points A, B and C are all on the circumference of the circle. O represents the centre. Angle DOB equals 2x plus 28, and angle DCB equals 3x minus 70. And we need to calculate the value of x. So first of all, I'm going to find DAB. I know DAB is the angle at the circumference, and this angle here of 2x plus 28 degrees is the angle at the centre. I know that the angle at the circumference is half the angle at the centre. So I know that DAB can be written as x plus 14 degrees. I also know that ABCD is a cyclic quadrilateral. Opposite angles in a cyclic quadrilateral add up to 180 degrees. So I know that 3x minus 70 degrees plus x plus 14 degrees is going to add up to 180. And I can use that fact to work out what x is. So I'm going to have 3x minus 70 degrees plus x plus 14 degrees is equal to 180 degrees. I'm going to simplify that. So remember, if you get a bit shaky with where your positives and negatives go, lines before the signs. 3x plus x will give me 4x. Negative 70 plus 14 is going to give me negative 56 degrees. That's equal to 180 degrees. Then I'm just going to add 56 degrees to each side. So that's going to give me 4x is equal to 236 degrees. I'm going to divide both sides by 4. That's going to give me x is equal to 59 degrees. Thank you for watching.